Welcome back to the Deep Dive. Today, we are opening up a stack of reports that, on the surface, looks like it's about education policy in the Caucasus. But when you actually start reading, you realize it's about something, well,
hmm
something much more universal. It's about that fundamental gap between knowing something in your head and actually being able to do it with your hands.
That is the eternal struggle, isn't it? The gap between theory and practice. We see it in everything from medical school to, I don't know, learning how to drive.
Exactly. And the solution proposed in these documents involves a technology that I think most of us still associate with teenagers in their living rooms. We're talking about virtual reality or VR.
hmm
But, and I want to be clear right off the bat, we are not talking about video games here. We're not talking about slicing blocks with lightsabers. We're looking at why VR is shifting from a nice-to-have luxury into an absolute economic necessity for vocational education and training, or VET specifically in Azerbaijan.
It's a fascinating case study because it completely flips the usual narrative. We think of VR as this high-end, expensive toy. But in the context of Azerbaijan's industrial sector, the argument is that VR is actually the frugal, practical choice. It solves these structural problems that traditional classrooms just can't touch.
And the stakes are high here. We're not just talking about making school more fun. The sources are surprisingly blunt. They argue that the current way of training the workforce, which is often passive, book-heavy, or reliant on outdated machinery, is becoming a bottleneck for the entire economy.
It's a huge bottleneck.
So we have three big things to unpack today. First, we need to understand this safe failure revolution, how VR actually rewires how we learn skills. Second, we have to look at Azerbaijan specifically. Why is this so strategic for them right now? And third, we're going to get into the nuts and bolts, the actual scenarios. How does a headset teach you to weld or fix a high-voltage cabinet?
And that third part is key because that's where the impossible trinity comes in.
The impossible trinity.
Yeah. In vocational training, you're usually juggling three things: safety, cost, and access. And normally you have to sacrifice one to get the other two. If you want it safe and cheap, it's probably not very realistic, so you lose access. If you want it realistic and safe, it's probably incredibly expensive, so cost goes out the window.
Right.
The argument here is that VR is maybe the only tool that lets you solve all three at once.
Okay, I like that framework. Let's start with that first pillar, the global context and this idea of safe failure. The source material makes a really interesting point about the psychology of learning trades. It suggests that traditional training is often, well, terrified.
Terrified is a strong word, but it's pretty accurate. I mean, think about it. Put yourself in the shoes of an 18-year-old apprentice. You're standing in front of a massive industrial power distribution board for the first time. It's loud, it's dangerous, and you know that one wrong move could destroy equipment worth more than your family's car, or worse.
Or send you to the hospital.
Right.
So you're not thinking about learning, you're thinking about survival.
Exactly. Your cortisol levels spike. You become risk averse. You don't experiment. You just try to follow the instructions perfectly so you don't get yelled at or get hurt. That is not an optimal state for learning.
Not at all.
The safe failure revolution is about removing that physical risk. In a VR environment, if you cut the wrong wire or you overload the circuit, the room doesn't explode, the screen just turns red, you get a critical error notification.
It gamifies the disaster.
It de-risks the entire learning loop. And the data we have from global industry shows that when you remove that physical risk, students actually learn faster. They become curious again. They say, I wonder what happens if I turn this valve. And they do it. And they crash the system. And then, and this is the magic part, they hit reset.
That reset button is so powerful. And it allows for repetition, which brings up another point from the sources, repetition without waste. I hadn't really thought about the physical cost of just practicing.
Oh, it's massive. Take welding, which is a core skill in Azerbaijan's industrial sector. To train a certified welder, that student needs to burn through hundreds of welding rods. They need sheets of scrap metal, they need gas, and they need an instructor watching them like a hawk every second to make sure they don't, blind themselves or start a fire.
So every single hour of practice has a literal price tag attached to it.
A very high one. But in VR, you can run that same bead of weld 50 times in an hour. No scrap metal, no gas, no fumes. You can practice until your hand movement is perfect muscle memory.
And the machine doesn't get tired or wear out. That leads us to the issue of standardization. I think everyone has had that experience in school where you feel like your grade was a bit subjective. Like maybe the teacher just liked the other kid's work better.
It's a huge issue in vocational trades. I mean, how do you objectively grade someone on operating a forklift? Usually it's just the instructor watching and ticking boxes on a clipboard. It's subjective. Maybe the forklift student A used had better brakes than the one student B had? VR eliminates all those variables?
The simulation's the constant.
The simulation is the constant. Every student faces the exact same wind speed on the crane, the exact same friction on the weld, the exact same emergency alarm.
So the system spits out the data.
It gives you objective metrics. Student reacted in 3.2 seconds, student checked mirrors 4 times. It just removes the bias.
Okay, so that's the promise of the tech. But let's ground this in our specific geography. Why Azerbaijan? Why is this getting so much attention in Baku right now?
Well, you have to look at the macroeconomics. Azerbaijan is in a major transition phase. For decades, the economy has been, heavily reliant on oil and gas, but they have a strategic mandate to diversify. They want to build up logistics, agriculture, IT, green energy.
But you can't build a logistics hub without people who actually know how to manage the logistics, right?
Precisely. You can build the warehouse, buy the trucks, and install the software. But if you don't have the technicians, the operators, and the safety managers, that infrastructure is basically useless. The sources highlight that employers in Azerbaijan are just crying out for job-ready staff. They don't want someone who's read a book about hydraulics. They want someone who can diagnose a leak on day one.
And there's a demographic angle here too, right? The sources mention social inclusivity and reskilling. This isn't just for teenagers leaving school.
No, and that's critical for a changing economy. Imagine a 45-year-old worker who spent 20 years in a sector that's now shrinking. You need a way to pivot them into a growing sector, say, solar energy installation, and do it quickly. You can't send them back to university for 4 years. VET needs to be agile, and VR allows for that rapid, modular retraining. You can put them through a solar installation boot camp in VR and get them field ready much, much faster.
So the sources list 3 main drivers for this: labor market demands, economic diversification, and social inclusivity. But I want to drill down into that labor market piece. There's phrase here, safety culture. It implies that the current workforce might know the tasks, but lacks the mindset.
That is a very common friction point in developing industrial economies. You often have workers who are very clever at fixing things, jury rigging solutions to keep the machine running. But modern industry, international standards, ISO certifications, it requires strict adherence to protocol. It's not just, did you fix it? It's, did you lock out the energy source, tag it, test for zero energy, wear the correct PPE, and then fix it.
And VR forces that compliance.
It mandates it. In the simulation, if you don't put on your virtual hard hat, the system won't even let you enter the construction site. It builds the muscle memory of compliance, so it just becomes second nature.
Let's get specific now. We talked about the impossible trinity: safety, cost, access. The source material breaks down how VR solves these specifically for the Azerbaijani context. We've touched on safety, but I want to talk about the lockout-to-goat scenario. This seems to be a flagship example.
It is. Lockout to goot, or LOATO, is the absolute golden rule of industrial maintenance. Before you service a machine, you ensure it cannot be turned on. In the real world, training this is hard because you have to shut down real equipment, which costs money. And if you practice on dummy equipment, the student knows it's fake. They don't feel the weight of the decision.
Because they know they aren't actually going to get electrocuted.
Right. But in VR, the scenario can simulate the consequences. If they skip a step and touch the bus bar, the screen flashes with an arc flash explosion. It's visceral. They remember that mistake because the brain registers the shock of the event, even if it's virtual.
Then there's cost. We talked about consumables like welding rods. But what about the equipment itself? The sources mention that outfitting every vocational school in Azerbaijan with modern CNC machines is, well, it's financially impossible.
It's just a numbers game. A high-end 5-axis CNC machine can cost hundreds of thousands of dollars. You can't put one of those in every regional college from Quba to Lankaran. It's just not feasible.
Yeah.
So you end up with students learning on these 30-year-old machines that aren't even used in the industry anymore.
So VR acts as what the sources call a preparation layer.
Exactly. Think of it like a flight simulator for trades. You don't put a trainee pilot in a Boeing 747 for their first lesson. You put them in a box on the ground. Similarly, you let the vocational student crash the virtual CNC machine 100 times. They learn the control panel, the programming, the setup. By the time they actually get to the one real machine the school owns, they're competent. They're not wasting time figuring out where the on button is.
It maximizes the utilization of the real assets.
And it solves the access problem. You can distribute the software to 50 schools instantly. You can't distribute 50 industrial robots instantly. It democratizes the quality of education across the entire region.
Now, I want to challenge this a little bit. We're talking about simulating work, but surely there are things you can't simulate. The weight of a wrench, the smell of burning rubber. The source material includes a list of tailored scenarios specifically for Azerbaijan. Are these actually realistic?
That's the skepticism we always encounter. And it's valid. VR can't replace the physical sensation of weight or heat, at least not yet. But look at the specific scenarios they've proposed. They're clever because they focus on procedural and perceptual skills.
Give me an example. The energy and industrial maintenance one mentions diagnosing faults via sound.
This is brilliant. Experienced mechanics don't just look at a pump, they listen to it. They know the difference between the high-pitched whine of a bad bearing and the sort of gravelly sound of cavitation air bubbles in the liquid. VR is perfect for this. You can put the student in a virtual plant room, turn the spatial audio on, and say, find the failing pump. They have to walk around and use their ears.
So you're training a sensory skill, not just a manual one.
Correct. Or take the oil, gas, and petrochemical scenario. Azerbaijan deals with high-pressure systems. The training here isn't just turning valves, it's about emergency response. A gas leak alarm goes off. What do?
In real life, you run.
Hopefully not just run. You need to check the wind direction sock. You need to grab your emergency breather. You need to follow the designated escape route. You can't practice a full-scale gas leak evacuation in a real refinery without shutting down production. In VR, you can do it every Friday afternoon.
The list goes on. Metal and machine building, logistics, construction. I was interested in the agriculture one. Tractor hydraulics.
Yeah, agriculture is becoming much more mechanized in the region. Modern tractors are complex pieces of hydraulic engineering, and connecting high-pressure lines incorrectly can inject oil straight into your skin, a terrible injury. VR allows students to practice the connection sequence safely over and over.
And renewable energy. Solar panel mounting.
That's a booming sector, and it's not just bolting things down. It's working at heights, on slanted roofs, handling electrical components. The Working at Heights VR module is incredibly effective because it can actually induce vertigo. It tests if the student clicks their harness in. If they don't and they slip, they fall. The brain registers that fall.
But, and this is a big but, that the sources emphasize technology alone doesn't fix education. You can't just buy a crate of headsets, drop them in a classroom in some quiet, and expect the workforce to magically transform.
That's the field of dreams fallacy. Build it and they will come. In EdTech, it's buy it and they will learn. It never works. The hardware is the easy part. The sources outline a 6-step implementation model specifically to avoid this failure.
Let's walk through those steps. Step 1 is needs analysis.
Right. Don't guess. Don't just buy a generic VR package. You have to go to the employers, the oil companies, the construction firms in Baku, and ask them, what are your rookies bad at? Where are your accidents happening? You build the curriculum backward from the problem.
Step 2, priority selection.
Focus. You can't simulate everything. You have a limited budget. Pick the top 8 to 12 scenarios that are either too dangerous, too expensive, or just plain impossible to teach in a classroom.
Step 3 is localization. This seems absolutely crucial for Azerbaijan.
It's non-negotiable. You can't just license a VR module from a company in Chicago or Munich and expect it to work perfectly in Azerbaijan. I mean, language is the first barrier, obviously, but it goes deeper. The safety signage needs to look like local signage. The equipment needs to resemble what they will actually see in the field. If the VR forklift has a completely different control layout than the Soviet era or modern Chinese forklifts they use in the warehouse, the training transfer is low.
It breaks the immersion.
And it creates confusion. The protocol has to match the local regulations.
Step 4, teacher training.
This is where most projects die. If the teacher feels threatened by the technology, or if they feel stupid because they don't know how to turn it on, they will just leave it in the cupboard. You have to train the teachers not just to use the headset, but to use the data. The teacher needs to look at the dashboard and say, okay, Orkhan, I see you hesitated on step 4. Let's talk about that. The VR is a tool for the teacher, not a replacement for them.
Step 5, pilot and measurement.
Prove it works. Run a pilot in 1 or 2 locational centers. Measure the results. Did the students learn faster? Did they make fewer mistakes when they got to the real machine? You need those KPIs, key performance indicators, to justify the budget for the final step.
Which is step 6, scaling.
Once you have the localized content and the proven model, then you roll it out to the network. You build a centralized library. So a student in a rural vocational school has access to the exact same high-quality training scenarios as a student in the capital. It truly democratizes the quality of education.
It sounds like a systemic overhaul. It changes the definition of what it means to be educated in a trade.
It shifts the currency from time to competence.
What do you mean by that?
Well, traditionally, we measure education by time. I spent 60 hours in the welding class. That doesn't actually mean you can weld, it just means you were there. VR produces what the sources call a digital competence portfolio, it says. This student has successfully completed the vertical weld seam 40 times with an average accuracy of 95%.
That is incredibly powerful for an employer.
It removes the risk from hiring. You aren't taking a gamble on a certificate. You're hiring based on verifiable data.
So, to wrap this all up, we started by saying VR isn't just a toy. I think we've pretty thoroughly proven that. In the context of Azerbaijan's industrial ambitions, it acts as a strategic asset.
It is an accelerator. It accelerates the creation of a skilled workforce, which in turn accelerates economic diversification.
It bridges that gap between the classroom and the reality of the workshop, removing the danger, the cost, and the bias along the way.
And it gives students the freedom to fail safely, which really is the only way we truly learn anything.
I want to leave you, our listener, with a final thought, something hinted at in the reports. We talked about this digital portfolio. Imagine a near future in Azerbaijan where a young person doesn't just walk into an interview with the CV, but with a tablet showing a replay of their perfect safety run in a virtual refinery.
A verified digital twin of their skills.
Exactly. If that becomes a standard, how quickly does the entire labor market change? It forces every training provider to step up. It makes skill transparent. It's a fascinating prospect.
It really is. It's the modernization of the workforce, one headset at a time.
Thanks for diving deep with us today. We'll see you on the next one.
Co-funded by the European Union. Funded by the European Union. Views and opinions expressed are, however, those of the authoress only, and do not necessarily reflect those of the European Union or the European Education and Culture Executive Agency, EACEA. Neither the European Union nor EACEA can be held responsible for them.